All right, so a little bit of everything today. Kind of look here. So that homework is due kind of next week, a week from today. One thing that I was going to mention today is, and I'm not sure exactly what I'll do. I'll probably just post a video, kind of going over just kind of the next topics for next Thursday. So the day when that's due, if you want to turn in a hard copy, you can slide it under my door of my office, or turn it in, I guess, on Tuesday's class, because I actually have to, my wife's having surgery, so I will not be available on Thursday. So I'll get up a replacement video for class after we have class on Tuesday, so that you'll have that, and I'll kind of expect that you watch that before the next Tuesday's class. Okay, so next Thursday, we won't be meeting here in class. I won't be available on Thursday. So that kind of takes care of that. Move this over here since this is no longer due. You got that homework. So if you've got last minute questions, kind of plan on that next week. You won't be able to ask me Thursday. So Monday through Wednesday, I'll still be here and available, okay, during office hours. Any questions from me before we kind of get into things here today? Okay. So we left off, we were talking about kind of statistical discrimination, but also other types of discrimination, employer, employee, consumer, how they all worked. We'll talk a little bit about some positional discrimination stuff. I think I'll probably transition and save this in case we have time to do some gender discrimination. I want to show you some stuff in Excel, and then we'll have this paper that I want to take a look at as well. So where are we at? There we are. So we talked about a little bit, statistical discrimination. We kind of can see this play out with positions, specifically in baseball. So it's kind of a good example of this, where teams are making decisions based off of group means, right, or group averages. But any one individual could come from any part of that distribution of quality. Right? So kind of look here at the kind of breakdown. This is like, using some older data. But, you can see that if you just use 4 racial categories here, we could break it down even further, but this is kind of what they tapped at those 4. I mean, you can see like outfielders, there's a lot more in certain racial groups than there are, third basemen or shortstops, right? So there's different racial compositions in every single position. So if teams kind of use this as an indicator for potential quality, potentially if they're looking at this, they might underpay kind of African-American catchers, right? Because on average, or give them fewer opportunities, because on average, most of the ones who kind of end up starting and playing tend to be white. Now, how far back does this go in terms of kind of like the coach positional discrimination we talked about, where it was allocative? So it was happening at the lower coordinator levels, and we just looked at the number of head coaches. Well, then as a result of the discrimination that was existing kind of earlier on, right, it looks like there's discrimination at the head coaching level, although it's really existing further back, right? So same kind of thing here. We don't have college or minor league data or anything, but potentially that's what's driving some of this. Okay. So if we looked at these positions, right, we know that there's different racial breakdowns on each one of them. Well, I also look at the average starting salary of every position. First baseman and kind of starting pitchers are the highest. So if we go back here, first baseman, where is it? There it is. Well, that's predominantly white players, right? If we're looking at, it's, and then kind of pitchers, it's also has a higher probability. Right? So just by nature of the racial breakdown of each position, if certain positions are valued more, then when we look at the overall averages, it's going to look like, white players are earning significantly higher here, right? Because they tend to be in the positions that have the highest salary. Now, is that a result of them actually being in more productive positions, adding a higher number of additional wins? Well, that's a separate question, right? Although I believe some of the research out there, if I'm recalling it correctly, I don't know about first base, but starting pitchers tend to have higher marginal wins kind of coming from their labor than positional players, right, in baseball. And so, that would kind of justify those higher salaries. And, the reverse works as well. If we're looking at, I don't know, let's see what the lowest one is. So if we're looking at like shortstops here, and kind of they're predominantly kind of like, they call it Latino here, but I think this is a dated paper, right? So, but if we look at the position of shortstop, well, that has one of the lower salaries. So the only other lower one is kind of relief pitchers here. And so that's going to make it look like Hispanic players are being paid significantly less, right? And a lot of that could be just driven by positional differences. So when we run regressions, we're looking at trying to uncover discrimination, right? We would want to make sure we're controlling for position. And this is not just specific to baseball, but probably any sport, right? There's going to be different marginal wins for labor coming from different positions. So we can kind of match this up with what we've already done a little bit of. So kind of imagine these positional differences. So we've got our quantity of labor and our wage. And let's just assume for a second that the supply of labor is the same for, what was the big discrepancy? Shortstop and first base, right? There's the same supply of labor, right? They both have the same marginal cost to supplying their labor. Okay. Well, if the demand for labor is the marginal revenue per win times the marginal wins coming from that labor, well, let's just assume we're looking at the same team, right? Same team kind of paying a shortstop or a first baseman. Well, that marginal revenue per win is the exact same, right? So if you're here, we'll say first baseman. Right? But we know that if the marginal wins that come from labor for a first baseman are greater than that of a shortstop, right? This kind of representing the demand for labor for a shortstop. Well, if that demand curve is higher, right, then we're just thinking about equilibrium wages here, we would expect that the wage for a first baseman is significantly higher than that of a shortstop. So it may not be driven by discrimination at all. It may simply be based off of the marginal wins that come from playing that position. And certain positions might have greater than others, right? Quarterbacks may impact the game more than your holder for your kicker, right? So we would expect there to be kind of those wage differentials. The issue is we looked at predominantly first basemen were white and shortstops were Hispanic. And so that's going to cause some kind of wage gaps if we want to think about it there, right? But it may not be a result of discrimination at all. In fact, I don't think this is the case, but just an interesting thought experiment. It would probably work better if I had a higher paying position that was a group we think might be discriminated against. But let's just assume for a second that white players who play, overall are kind of, discriminated against. Then even seeing a higher salary paid to first basemen, maybe it's just that it's not as high as it should be. Right? If there's employer discrimination going on, we kind of expect that to decrease our demand curve, resulting in kind of lower, so first base with discrimination. Now, I don't think that's the case. I'm not saying that in Major League Baseball that white players are being discriminated against, but it could shift down kind of that demand curve as well if we had kind of the reverse. So maybe something like, I don't even know a great example off the top of my head, where we see like different racial compositions in different positions, but potentially if we do have this marginal wins for labor be higher for one position, it could mask some discrimination. Because we would look at this and say, well, yeah, the wages of the position that has this group that's being discriminated against, well, the wages are still higher than the position where it's predominantly the non-discriminated against group, but they're not as high as they should be. And it's, we can't observe this demand curve. All we can observe are the actual wages and salaries paid to players. Okay. Any questions on what I did here? Okay. Just trying to kind of relate to some stuff we've already done, thinking about these kind of more intuitive things, right? So, it's really a self-fulfilling prophecy, right? We talked about last class that maybe now as a result of this, maybe fewer African-American players are given a chance to play shortstop. Maybe fewer, where's the other one? Where was here? Or maybe, more Hispanic players are given an opportunity to play shortstop, which is then going to, because of this belief, we're just only giving opportunities to the group that is already kind of predominantly filling that position. So it could be this self-fulfilling prophecy. I think about examples here. You could run through a bunch of different hypotheticals. I kind of like this. I did this graph for the first baseman shortstop, so that was kind of the example I used. But you could think about there could be positional differences. I think the NFL makes a lot of sense, where you might have different racial compositions at each position, and we know that different positions in the NFL are paid significantly different salaries on average. Okay. So we'll go skip on gender discrimination now. And we'll do a little bit of kind of regression stuff, kind of relating to this idea of racial discrimination. So this is a pretty interesting paper, relatively new. 5 years is not that old when it comes to kind of looking at some of these published papers. And so we'll scroll down here and we'll just kind of look at, if I can find their regression equation. Here's their first, that's not what I want. I want the regression equation, which is right here. Right? So generally, you could have read all those pages and probably gotten a much better idea about what they're doing here in this paper. But if you look at this regression equation, we should kind of be able to work backwards, right? So their Y variable here is followers. So usually before they put this, they'll kind of have these different variables, or sometimes it's after. So let's see here. It's probably going to be after. Yeah, here it is. They got a whole table for it. Followers represents the total number of, I believe this is Twitter followers that an MLB player has, right? So that's going to be our dependent variable. Yeah. Yeah, so it's a good question. Oh, am I not? Nope, I don't know if I was showing any of that in the video, but it's okay. So we've got our dependent variable being followers here. So if we want year indicators, like let's just go from a simple naive, like we're not even considering like identifying discrimination yet. So if I've got the number of Twitter followers for these players, and I've got some intercept, and maybe I think, well, that's been changing over time, right? As Twitter gets older, I probably would see just the number of followers for everybody go up, right? And so maybe I think, okay, I should include this year variable, right? To kind of capture the fact that Twitter was growing in popularity over this time period. The problem is what that does is it forces there to be, and so let me think, there we go. Maybe it dropped in this year. So I have all this data, and maybe instead of like, if I'm trying to estimate this coefficient, what I'm trying to do is come up with a slope that best fits the data. Well, if the data is kind of jumping all around, not following a linear trend over time, I might get that the effect of the year is like not significantly different from 0. But actually what it's doing is, right, it's jumping around. It just has this very non-linear form. So to not go into too difficult of ways to deal with that, one really easy way is to instead include what we call dummy variables, which all a dummy variable references, or I usually call them indicator variables. So it just means it's a 1 or a 0, right? And so if we've got this variable of year, I think we kind of talked about something like this, like conference as an example in the past. But what I could do is say, okay, here, I'm going to include, and I forget the time span, but we'll just say it started at, I don't know, 2012, right? So I'll include this variable, which is a 1, if the observation was from 2012, 0 if not. I'll then include another indicator variable for 2013, 1 if the observation, and I basically will just include all these indicator variables for every single year, right? Now, when I run this regression, if I do it in Excel, and I think I've got an example I can show you today. Yeah, the data set has something I can show you this. So it'll just drop one of them because you need to have some comparison group, right? So you can include all of them and Excel will automatically drop one for you, or probably better practice is just leave one of them out, right? You only need to include an indicator for every single year except for 1. Now, what this does, it allows to say, well, in 2012, the additional increase or decrease in followers was whatever this coefficient is. And so when you're making your predictions, it jumps up here. And then 2013, it would jump up a whole bunch more, as opposed to forcing this kind of constant like linear trend. Does that kind of make sense? Yeah, so sometimes I forget that they are referred to as dummy variables. I always call them indicator variables, just a 1 to indicate whether or not the observation belonged to that group, in this case, years. Yep. So, and it's an easier way to write that is to say year dummy, which means that, you're including all these year dummies as opposed to like having to show, let's say we had a 20-year time period. I don't want to show you 20 different indicator variables. So they've got all these other different controls as well. So the position the player played, the number of games, a measure of their productivity, which we could go down here. I don't know what they used here. Did I already skip up by it? Player productivity. Why am I not seeing this? Oh, so once again, sometimes when you see these regressions in these papers, they'll use a name to reference, like they included all of these different measures of performance, right? So it wasn't one simple measure, but it was, right, they're saying we included several different controls to control for player productivity. They then included the race of the player, and then they included these percentiles. So what were these percents? If we go down here, they were the percent of the local MSA, or which stands for Metropolitan Statistical Area, right? So basically the city, if you want to think about it that way, the kind of racial demographics of the city, right? So their idea was, well, if a player is of a certain race, like obviously they might have more Twitter followers if, especially in Major League Baseball, we've got, several different cultures represented. So maybe they would just have more followers if they were in a city where there was more people of the same race, right? So we want to make sure that we control for kind of those demographics. And kind of they have other quality measures, like were they an all-star? There was a team in the playoffs, right? Because that could increase how many eyes are on the player. They included what their age was, the number of years they had in the league. Don't worry about these squares. That's just another way we can capture these nonlinear effects, but I'm not going to expect us to know it, so we can kind of ignore those controls for right now. And basically, if they estimate this, what they're hoping is that when they look at these indicators here for whether the player was white, African American, Hispanic, or Asian, well, hopefully these are all not significant at all, right? Hopefully they're no different from zero, because we would hope that in society, like people aren't looking at race as whether or not they should like this player. Now, this is the general idea of what they were thinking about. So we can run this regression and kind of look at those coefficients on our race identifiers, holding everything else constant. So the thought experiment, this is why linear regression, like I keep showing you examples, and hopefully we're kind of understanding, like even at this simple level, really allows us to make more optimal decisions. It's like saying, okay, take two players from the same year. Their statistics are exactly the same, right? Same number of home runs, same batting average, everything. They play the same position. They played in the same number of games. Their team had the same number of followers, right? And all these other things are exactly the same, but one of them is white relative to whatever the racial group that we left out was. I forget exactly here which one they end up leaving out, but that's pretty powerful, right? So we'll scroll down here and kind of look at their results. So they did this. These are summer statistics. Their results, which is right here. So here's one that they did just for offensive players, right? Batters. Okay. Now they did 3 different regressions, so 3 different models. And we kind of scroll down to the bottom. Usually that shows us, oh, we were using different statistics in these different models. So one of them they used on base percentage, one they used slugging, one they used kind of OPS, right? And just to see, just give us any different measure, right? Maybe some of these measures are better for player productivity than others. So we'll go up here. I don't know why they didn't order them nice for us, but we can kind of go down and find kind of these racial indicators. So they left out white. So everything is going to be relative to a white player. What's the expected or predicted change in our Y variable, which was the number of Twitter followers, if a player is African American, or if a player is Asian, or a player is Hispanic. Now, they use stars to kind of indicate whether or not things were significant. So if we're looking at these coefficients here, they have standard errors, but we're not really using standard errors for anything in this class, but we would use them to come up with whether or not this is significant. So they show you here, the only one that's significant looks like is for Hispanic players. There's a significant kind of expected or predicted decrease in their Twitter followers, right, relative to a white player, holding all this other stuff constant. Right? And I think that kind of comes out in every single one of their models, right? So that's the only one where they really find significant effects. They do find negative coefficients on this African American indicator, and then some positive coefficients for Asian, but they're not statistically any different from zero, right? The results weren't strong enough to where we can actually say there's an impact. So this is some evidence that maybe, once again, there's some consumer discrimination going on, right? Now, it's through Twitter followers, I don't know how I don't know how much we should take this and then transfer it into people are not going to watch games or anything like that. But it is kind of some interesting evidence, right? That maybe we have some discrimination going on, at least on the social media market. They did the same thing for pitchers. So once again, we'll come down, look at these. Well, here they find a pretty significant impact for Asian pitchers, right? Relative to a white pitcher, if the player was Asian, holding all these other things constant, they can expect a significantly higher number of Twitter followers if they're Asian relative to being white. Now, what might be driving some of this? You've got Asian players and they're not Asian American. Potentially you have an entire different kind of, you know, you're opening your fan base open to an entire different country, right? So maybe that's what part of this is, right? Maybe it's less discrimination and some, you know, more of, you know, maybe different cultures are more represented on Twitter than others, right? If we're looking like around the world, we can think about, you know, economic conditions probably influence that. But they found a pretty significant effect. They found, once again, a negative effect for Hispanic pitchers. And then here, still, there's no real kind of difference between white and African-American players when it comes to the number of Twitter followers, right? Holding all this other stuff constant. So kind of interesting evidence, at least gives us more to think about. I think that this paper probably could have extended upon this and seen, you know, well, is there some interaction between their race and the racial demographics of the city they live in? Or, you know, their country of origin, maybe controlling for whether or not the player is American born or not, but I maybe didn't have data on that. So, but kind of an interesting paper that kind of shines some light that there maybe is some consumer kind of discrimination, or maybe not just discrimination, maybe we call this like preferences, kind of thinking about maybe there's ties to nationality and things like that going on. But gives us a pretty good, I don't know, kind of regression example. So we'll kind of keep working, thinking about linear regression and kind of stray from discrimination for a little bit here today. I don't know how long we'll work on this, but we may return to kind of gender discrimination at the end of class. But I want to make sure that we have a pretty good understanding of how do we take some data, get regression results, interpret those regression results, and make some interesting statements with them, okay? So this time, I promise that I've cleaned up this data set. Triple checked it. So it's probably too big. So let's blow this up a little bit so we can see it. So I think this was 2010 to 2019. I had every NFL play. Now it's difficult to work with play-by-play data, but I was just thinking, it might be interesting. We've talked about the hot hand a little bit, right? So if I may make the previous shot, am I any more likely to make the following one? Maybe the same thing could be going on with field goal kickers, right? I don't know if you've ever watched an NFL game and a play, kicker misses one or two. Oh, he's cold today. Oh, he's off, Well, as the last one still in his mind, So is there any kind of carryover from missing a field goal or making a field goal onto the next one? So it could be interesting. So I just kind of pulled out every single field goal. You can kind of see how the play-by-play data has all this goofy stuff in it and you can use it, but we won't worry about that. What we're really kind of focused on is going over here. So for every player, we kind of have whether or not the field goal they kicked was made. We have the seconds that we're at in the game, right? So as we get kind of towards the end of the game, the seconds is going to get higher and higher. We've got the quarter that it was taken in, the yards that they would have had to go if they didn't kick it. We've got the distance of the field goal, the score differential at the time. I believe here, so it's the kicker's team. If it's positive, that means they were up by 3. If it was negative, it means they were down by, down by 7. Okay. And then we have whether or not they previously made their field goal. So pre-field goal made. I've got the number of field goal attempts that they took within this time period. And then I have what their field goal percentage is. Right? So this is kind of trying to control for their overall quality. Of all the kicks they've taken in the NFL, what percent of them, and here a kind of different proportion, I guess I shouldn't have called this percent, but what proportion of them did they usually make, right? So kind of trying to control for quality there. So a couple things we could do. First of all, let's just run kind of our simple, maybe a naive regression. So we'll go to data analysis, scroll down here to regression. My Y variable is whether or not they made that field goal. Okay. So kind of some shortcut, Control Shift or Command Shift on a Mac, and I hit the down arrow, it'll select the entire column of data for me. So if you've got these larger data sets, that's really helpful as opposed to dragging with your mouse. So once again, that was Control Shift, hold Control Shift, or hold Command Shift, then hit the down arrow. We're then going to go to what control variables we want, or what variables we want on the right-hand side. Well, for now, let's just look at, did they make the previous field goal? Very naive, we're not controlling for anything. So Control Shift or hold Command Shift on a Mac, hit the down arrow. When you do this, you should have the same, have the same starting point and the same ending point in terms of your row reference. I selected the very first cell, which was the labels, so I got to make sure that's selected. I'm going to put this on a new worksheet, so I hit OK. So I'm going to move this over. Just go call this naive, right? This is our naive regression. So here, it looks like if I make the previous field goal, I'm actually a little bit less likely to make the next one. Right? Now, the p-value is 0.67. So we haven't had this discussion a little bit, but if that p-value is 0.67, what does that mean? Yeah, I can't say that it's anything different from 0, right? So just a reminder of what we're doing there. So anytime we see a p-value less than what we'll call alpha, which is just kind of varying levels of confidence, right? So our alpha values of 0.1, 0.05, and 0.01. We said when we look at these stars, another way to think about this is really, can I reject a null hypothesis with 90%, 95%, or 99% confidence? And when I say rejecting the null hypothesis is just what we assume to be true, which is that, and I shouldn't have put 0 here, just whatever coefficient we're looking at, I. We always assume it's equal to 0. So we always assume there's no relationship between our x and y variable. If we find a low enough p-value, we can then start to reject that assumption. So here with 0.67, I mean, we're not even close to being less than even the 90% confidence alpha of 0.1. So here we can't say it's any different from 0. There's no effect from making the previous field goal. Okay. So that's kind of our naive regression. But we know that, well, maybe making field goals, if I'm looking at the same game, maybe game conditions can impact things, maybe the quality of the kicker, right? If I'm not very good and I missed the previous one, I'm probably less likely to make the next one too, right? And so we want to make sure we're controlling for some of these things. So we'll go back to our data, which I think I had here on, what was the other one? Oh, I did this earlier and I didn't mean to save it. I'm going to delete sheet 2. We'll recreate it here in just a second. So I've got my original data. I'm going to look at this and say, well, I could include how many seconds have went by in the game, the quarter that we're in, right? As I get towards the end of the game, maybe that impacts, right? There's additional pressure, the yards to go. So maybe, I don't know, if we're really close to a first down, maybe there's more pressure on me to make the kick, than if we weren't. We've got the distance of the kick, the score at the time. We can include all of these additional controls. Right? So that's what I'm going to do. So we'll go to the data analysis tab, regression, all the way at the bottom. Now my Y variable is the same, but I want to include every single X variable. So I'm going to select those labels, hold Control Shift or Command Shift on the Mac, hit the down arrow, then I can hit, I don't have to hit enter, I can hit this little button here as well. It'll send me back here. I selected the labels, I'll hit OK. I'm going to call this more controls, right? So it's not naive, right? We've added in more controls, things that we think matter. Now, we might not have everything that we think matters, right? It would be ideal if we had like weather conditions and other things. They're just taking more time to build a much larger data set. But I think we've got a lot of the relevant example or variables. So we'll look at this. We've got 5,000 observations, which is quite a bit. We'll go down to our coefficients and our p-values for all these different variables. Right? So if I was looking at this and I look here, which of these variables can I say has a significant impact on whether or not I make the current field goal? Well, the intercept, we don't really have to worry about if that's significant or not. That's just going to help us make predictions. So it's not that we're saying that there's a relationship with the intercept and making it, just that there's some base level, right? So, if you make it to the NFL, even if all the conditions are against you, you're going to be more likely to make a field goal than someone who's not, or who wouldn't be. And there's some base starting point. So we look at the other variables. Is anything less than 0.1? So 0.2 isn't. Yeah, so if we see these E's, right, that means move the decimal point this many places. And if it's negative, to the left. So 100, so this is a p-value of basically 0. I mean, 126 zeros and then a 4, this is very significant. And that makes sense. Kick distance is probably one of the best predictors of whether or not a kick is made. Right? As they get further away, they're less likely to make that kick. In fact, we can do a little bit better interpretation here. So if I'm going to try to interpret a kick distance coefficient, right, our general interpretation is one more unit of X predicts that Y would increase or decrease by whatever that coefficient amount is. So here, what would one more unit of kick distance be? So I believe if we go back and look at it, it's one more yard. So one more yard, well, I can say this better. For each additional yard further the field goal is taken, the expected or predicted decrease, because it's negative, in the probability the kick is made is what? Negative 0.011, or sorry, we already said decrease, right? So for every yard further, right, for each additional unit that the X variable goes up, the expected or predicted decrease or change here, if it was positive, it would be an increase. And the probability the kick is made is 0.011. So usually the effect is this is how many more units the Y variable would go up or down by. But when we have this 1, 0 variable as our dependent variable, the units are essentially probability, right? How much more likely am I to be in that one group relative to 0? And a lot of these sports examples, a lot of times our dependent variable is a 1 or a 0, right? So, if we didn't have whether or not the kick was made, but maybe we had, I guess, the kick distance and I don't know, attendance at the game or something, right? Then that would be an increase in the number of people attending the game, right? The number of units of that Y variable. But here, with the 1, 0, our units, you can think about it's just probability. So, a probability of 0.01 is about 1%. So kickers are about 1% less likely to make a field goal for every additional yard that it's moved back further from the field goal post, right? So that's kind of interesting. Now, what if I wanted to do I can type. What if I'm thinking about what would the effect be if a kicker were to move 10 yards back? Well, if I know the effect of 1 yard, the effect of 10 yards would just be, yeah, I just take the number of units. If I know the effect of 1 unit, to get the effect of 10 unit increase, right? Moving 1 yard, now I'm moving 10 yards back. Just take the number of units you want to move times whatever that coefficient is, right? Or because I did 10, you could just move the decimal point here. But I could even do, well, maybe I'm not interested, maybe 5 yards back, right? And I could just get the effect of moving different amounts. And that's kind of interesting, depending on the example, maybe the units are really small, right? So if I'm thinking about something like, I don't know, maybe I have like, how is attendance impacted by win percentage? Well, I mean, in the NFL, the effect of a 1% increase, right? That's your units, like win percentage. Well, you never actually see a 1% increase, right? Because if I win one more game, the percent increase is what? 1 over 16 times 100, whatever that works out to be. And so maybe I know that more realistic things would be, well, what happens if the win percentage changes by 20%? Well, if I know the effect of a 1% increase, the effect of a 20 would be just that coefficient times 20, right? The number of units that you're actually interested in the impact or the effect of. Does that make sense? Any questions on what I'm doing there? So we can kind of just scale these coefficients, right? To get different, size effects. Looks like the only other thing that was significant here is the kind of career field goal percentage. Well, that makes sense, right? Like if I'm on average a higher field goal percent kicker, it's more likely I'm going to make my current one, right? And I might have an issue with this variable that actually could probably solve here, but I don't know if I want to waste too much time. So we'll go up here. I kind of notice, I mean, these field goal percentages are pretty high. I think I dropped kickers who had fewer than like 20 kicks in the NFL or something like that. So these are, career kind of kickers. They all are pretty high percentages. So one thing I wanted to show you, and actually your question was great because I actually had planned to do this, was to use this quarter variable. Well, what if like from the first, the second, and the third quarter, there's no really like additional pressure. There's still enough game to be played to where that might not impact the probability that they make the kick or not. But maybe in that fourth quarter, there starts to be a lot more pressure and maybe there's an impact there. Well, if I just include this quarter variable, it causes this to be linear. And in fact, it might be like zero effect and then jut up a bunch once I get to that fourth quarter. So I want to be able to capture that. So I'm going to leave out the first quarter. That'll be my control group, right? But I'm going to include dummy or indicator variables for every other quarter. So here we'll do quarter 2, quarter 3, and quarter 4, right? We want to create indicator variables. So one way that you can do this in Excel is using an if statement, right? So these if statements check to see if something's true. If it is, it puts something in the cell. If it's not, it puts another value. Well, we just want to create a 1, 0 variable. So we already know like we're either going to put a 1 if the statement's true and a 0 if not. So what do we want to check to see? Well, if this quarter variable is equal to, and here we want to know, is it equal to 1, right? Is it the first quarter? If it is, Oh, you're right. We're leaving out quarter 1. Thank you. Right? Yeah, this is the indicator for the second quarter. So we want to check to see if it's equal to 2. My bad. So if this is equal to 2, comma, put a 1. If it's not, comma, put a 0. And Excel kind of, well, before I close the parentheses, tells you like what it needs, right? Here's the test, comma, the value if it's true, comma, value if it's false. Okay. So we've got that. Now I want to do this for every observation. When I copy this down, what updates that cell reference to be looking at the quarter from that observation. Excuse me. So a good way to do this real quick is once I get to this black thick plus sign, if I double left click, it'll basically copy that all the way down to that very last observation in your data set. So that's a really nice shortcut, right? I don't want to drag that all the way down or type it out ever 5,000 times. So I can also do the same thing, but now is the quarter equal to 3, comma 1 if it is, comma 0 if it's not. And then if this quarter variable is equal to 4, comma 1, comma 0. And actually, so I've already got this filter on, so this would be a good one. What might I be forgetting if I only create these 3 indicators? Yeah, so if I go back here, I don't remember actually. So I can't remember if there is overtime in this data set or not. But if we had it filtered, sure enough, they coded it as a 5, right? So I could even just do overtime if that variable is equal to 5, comma 1 if it is, comma 0 if not. Right? So having it filtered was made it a lot easier to check to see, oh yeah, is there overtime data in here or is there not? Okay. And then double left click. Now we've got all of our indicators. So now I don't really want to include this quarter variable. So all of our variables have to be right next to each other. Once I include these indicator or dummy variables, I don't want to include the original one, right? The whole point is that original one forced it to be linear. I'm getting rid of that, replacing it with these dummy variables. So I'm going to insert a column here just so I can move this out of the way. Because when we go to run our regression, all of our variables have to be in what Excel calls it contiguous columns, right? Where the columns have to be all next to each other. Okay? So that's why I had to move that variable over. So now, if I go to my data analysis and regression, now I could do, whether or not it was made as my dependent variable, and then my Y variable now goes all the way out here. Control Shift, hit the down arrow. Got the same row, so that's good. Don't have any missing data or anything this time. So we'll go to View, We'll zoom in a little bit. And now I can kind of look at these results. Right? So what's kind of interesting here is, if I look at my p-values, okay, they're not significant, right? So it doesn't look like there's any additional impact from being, kicking a field goal in different quarters relative to the first. But maybe I just don't have enough data. And so maybe what do I do at this point? Right? Nothing's significant. Well, just because something isn't significant doesn't mean you don't want to mention the coefficient that you found. Right? So even though you didn't find strong enough evidence, you still found some evidence that said, oh yeah, you're actually more likely to make that field goal relative to the first quarter if it's in the third, fourth, or overtime is really close to it, but it's still positive, right? So you can still mention the size and the sign of the effect that you found. You just can't say that it's significantly different from zero, right? At the 90, 95, or 99% confidence levels.
This case, would you want to kind of read out over time since like it's so small and its p-value is so big?
Yeah, so I don't know if you necessarily want to leave it out. This time period, it's probably would have been a good case to just drop all those observations because this was still right. You only needed a field goal to win. I don't know what's going on here if things changed over that time period. But just because it's small doesn't necessarily mean that you just want to leave it out, right? You still want to control for it, even if you don't find a significant effect necessarily. Is there anything else I want to say here? So we included some of these indicators up here. One thing that you could do, and it's probably, outside of anything that we will or what we have talked about, but when it comes to like your project, if you're looking at your data, well, maybe here, I think, maybe it's that kickers aren't more or less likely in that fourth quarter to make it, right? So I was thinking maybe there's some additional pressure. So like what's going on? But maybe it's that it really only exists for these kickers who aren't really, really high quality. So I'm going to sort this field goal percent variable. And then I'm just going to kind of look here through the data. It's got a pretty wide range. I'm going to just choose a somewhat arbitrary point and say, okay, if they have a kind of lifetime percentage less than 85%, so 0.85 here, right? So I'm going to go up here. Oh, no, I'm not. I'm going to try to see if I can find it. Oh, so I'm going to go 0.85 right here, okay? So every observation below this are for kickers who have higher lifetime averages, everyone below it lower, right? So what I'm going to do is I'm just going to select all this data and put it on a separate sheet, right? So I just use the shortcut to copy it. I'm then going to paste it. And then I'm going to go back. Well, I also need to know the variable names. So I'm going to go all the way up to the top here. Hold shift and just hit over, or I could do this with my mouse. And I'm going to paste those variable names in there as well. I would probably then want to do the exact same thing, right? But I'm going to want to go down to the same point. But now I'm only going to take the kickers who are less than 85% lifetime. So once again, using Control Shift to kind of navigate quickly, hit the over arrow, hit the up arrow. It'll only select these observations for low field goal. So this one was, we'll call them low quality kickers. And then this one was for high quality, right? Now I can run two separate regressions and it'll tell me, okay, what's the impact of kicking a field goal in the fourth quarter for low quality kickers? And then what's the impact for high quality, right? Maybe for high quality kickers, it doesn't exist, but maybe for low quality kickers, they're actually less likely to make it, right? So we could kind of explore this. So we go up to, actually, let's do it for the low quality and just see if we find anything. We may not. I didn't look at this. I was just kind of thinking about, I wanted to show you an example. sorry, didn't mean to hit okay. So I went to my regression tool, right, under data analysis. I'm going to select this made variable, right, whether or not the kick was made. And then I'm going to go to my X variable and select everything else. Right? So hopefully I've got the same number of rows. I've got my labels selected. Now when I'm looking at these regression results, scroll down here. Now it looks like the fourth quarter, so it's still incident. So there aren't any differences, but that would be one way I could find, like, if I have two different groups, high, low quality here, I could think about if I run two regressions, I could then compare, well, what's the impact for low quality kickers of being in the fourth quarter? What's the impact for the high quality kickers? In fact, let me see. So if we're actually thinking about that initial hot hand idea that we kind of looked at, for low quality kickers, it looks like they're less likely to make a kick if they made the previous one, and it's just barely not significant. So this is a good example where, okay, yeah, this isn't technically less than alpha, but I mean, is 89% confidence that much worse than 90, right? It's definitely still worth mentioning, especially since that p-value is so close to being less than that alpha of 0.1. If we're gonna go, where was the other one that we did? Was it, I'm gonna delete this, I accidentally created that. Here it was, so this was, we'll call this quarter dummies, right? But if we looked at kind of that effect when we use the entire sample, notice it was negative, but not statistically significant from zero, right? So it was negative 0.01, and then when we did that for low quality kickers, well, now the effect is negative 0.03, and it is significant. So really, when you ran everything together, you were kind of getting the average effect of making the previous field goal across low and high quality kickers. Well, if the coefficient you find on that variable for low quality kickers is a larger negative value, that means that you were getting the average. It means that for high quality kickers, it must be that the coefficient was a little bit higher, right? So we can kind of test to see if that's true. So we'll go to that high quality kicker one. We'll go back to our regression tool. And when we have our made field goal variable, and then we have our, all of our controls. I select my labels, same number of rows, that's great. Now if I'm looking at this, sure enough, once I blow it up and you can actually see it, sure enough, for high quality kickers, so we'll call this high quality reg, and I'll post this after class so that you can kind of go back and look and see what we did. But notice now I actually get a positive coefficient for the high quality kickers from making their previous field goal. Not statistically anywhere close to being different from zero, right? A p-value of 0.8 is very high. So when I was running this all together, right, I was getting this result of, slight negative effect, not statistically different from zero. But when I separate it out by these two groups, I think might be impacted more, one impacted more than the other. Well, now for high quality kickers, there was no impact from making your previous field goal on whether or not you made the current one. But for low quality kickers, where is it? There we go. Who maybe we think might fall victim more to like this idea of overconfidence or something. Well, now if they make their previous field goal, they're actually less likely to make the next one. So, and it was very close to significant, right? I mean, might as well be 0.1067 is very close to being less than 0.1. So separating your data out into like groups and running like two separate regressions and then comparing the results can often like give you some pretty interesting insights into whatever the question is. Okay. All right, any questions or anything that we did in Excel here? I wanted to make sure that I got kind of worked through a pretty good example and show you a couple of little things, creating indicators, separating the data up. Now, I know I mentioned this before, but like good practice is always to do like this copy and paste thing because you want to make sure you don't delete any of the original data. Also, I don't know if it was this class, I do some of my stats class as well, but if where was one that I had filtered? I don't think I had any info, so I'll filter this. So one issue with, let's say I go to my original data and oh, hold on. I already have it filtered. So I go to here, and maybe I just start deselecting everything below 0.85 so that I only have that sample. But when I do that, it'll look like, okay, now I can run a regression. Like I can use a filter tool and then run my separate regressions. The problem is, notice, let's see, we need an example where it makes a jump. Oh, never mind, it'll only be the very first one. So notice it jumps from like 1 to 223. Those other 221 observations are still like in there, you just can't see them. So when you select that column, it'll select a bunch of the data that you aren't seeing, right? It's not actually like deleting the data or only using the data that you see. It's still kind of floating around in the background, right? So you can't just simply run 2 separate regressions in Excel using the same data set, which is why I kind of copy and pasted it into 2 separate sheets there. Okay. Questions on this? Okay. And there's other ways of doing this, but it's a little bit outside the scope of this class. Like in econometrics, you might talk about like interacting indicator variables and picking up, but that's kind of outside what I expect of you guys. So, all right. So I think we will go back to the slides now. So hopefully that kind of helps you as you're kind of starting, hopefully working with your project data, trying to come up with some results and then analysis of those results. And then just kind of getting more discussion from someone else's paper as well that we looked at. So we've talked about discrimination, and kind of the examples I've been using are predominantly race or kind of this foreign domestic. Those are probably the most realistic ones. And the reason why I don't necessarily give examples of gender discrimination is because we don't have a lot of like mixed gender leagues, right? And usually it's leagues have kind of their own, or each gender has their own league, and there's not a lot of cross competition play, right? But if there was, or we can kind of think about maybe differences between those 2 leagues. So NBA versus WNBA, right? Why do we see lower salaries in the WNBA? So we don't really have them often participating at the same venues, with the exception of, at the same time. So a lot of the times they share a venue, right? So, WNBA teams, share the stadium with NBA teams. If they had to build their own stadiums, I doubt you would see them be as large, because if we look at the revenue data, it tends to be lower for WNBA teams and NBA teams. Okay. So we don't often see mixed competition. There's some examples, right? But not a ton. So is the lack of women in these sports, right, discrimination, or is it something else, right? Well, there might be quality differences across gender, right, for various different sports. So we didn't have any discrimination. If we thought demand for labor is going to be a byproduct of 2 things: marginal wins that come from that labor or quality, and then marginal revenue per win. So when we're thinking about, even if we have the same sport being played, so let's think about the NBA, WNBA example. We have the same sport being played, but we know that one of the leagues, like the same sport, let's say like, not necessarily if they were playing against each other, but if we looked at the highest quality player in the WNBA and the highest quality player in the NBA, maybe they have the same number, or they add the same number of additional wins. So maybe we think about the marginal wins that labor's adding in each of these leagues is exactly the same, right? But the real driver there, because they're not necessarily if they like played against each other, I'm saying like as playing as separate leagues. But what happens is if we looked at kind of revenue data for the WNBA versus the NBA, we would see that the marginal revenue per win in the NBA is, probably to no surprise if you follow basketball at all, or just look at attendance numbers, significantly higher. Right? And so as a result, even if we had the same supply of labor curves, right? So the NBA and the WNBA had the exact same labor supply curves, we would expect that the demand curve WNBA players, even of the same quality, would be significantly lower than the demand for that player, for those players in the NBA, which result in significant, and I'll move my hand in a second, significantly lower wages. Now, we could have some consumer discrimination driving part of this, right? So like maybe, we see that women, or, basketball players or WNBA players make significantly less. And we're like, well, yeah, the marginal revenue per win is lower. But maybe it's also the case that, yeah, the marginal revenue per win is lower, but there's also like employer discrimination going on, which kind of causes this demand curve to shift down. And then we kind of call it, the wage and the WNBA, I don't know, with discrimination. Right? So it may be that, yeah, we do see lower wages as a result of this league having a lower marginal revenue per win, but there also could be some discrimination kind of in there as well, right? And this could be the same model would also reflect consumer discrimination. Okay? So, if there is discrimination, we never actually see this. All we see is there.
I also know that pay could be different by them choosing like a payment plan. So how would that be shown in a graph?
By the player choosing?
Like, I know like with soccer, for example, guys just like they get all the money and then they buy like their healthcare with that. While women get like benefits and
Yeah. So if we actually, this is going to be, when I say wages here, you bring up a really good question. So these are kind of like our general models. We can complicate this and have multiple markets, but probably a better way to think about this as opposed to just wages would be kind of using wages just to have an easier word. But it probably represents like total compensation. So if you took the entire value of everything given to them, so the value of the health, if it was free healthcare from the, if they get healthcare, the value of the healthcare plus their salary, plus any, discounts they get, you could add in everything. And that's really what we should be thinking about as wages is more of like total compensation or value of total compensation. If you look at data for like non-sports related examples, this becomes a lot more relevant, right? Because you can see people and you're like, well, why did this person leave a $70,000 job for a $60,000 job that looks almost exactly the same? And then you look at one of the, the firms wasn't offering him healthcare, the other was. So the actual total value might be significantly higher than his previous wage of $70,000 once you factor that in. But yeah, total compensation. Now, for the major sports, we probably don't have to worry about that as much, but you're right. When you go to sports that have significantly lower average salaries, those things start to become pretty important. That's a good question. Does that answer them? Okay. Any other questions on this model before we keep moving? Okay, so, if we looked at attendance numbers, and attendance doesn't tell us everything, but WNBA and NBA teams are generally using the same stadiums. So we can see WNBA attendance is less than half that of the average NBA team. Right? So if we're looking at wages, we would expect that, just from the ticket market, that might drive wages to be only about half, right? Or something. So we might want to, instead of looking at just the wage numbers, we probably want to start looking at, if we're comparing across leagues to look at gender discrimination, probably look at things like what percent of overall revenues are they getting paid in player salaries, right? Not any one player, but like all players, right? So what percent of overall revenue is the league spending on player salaries? And now there, if we see a discrepancy, well, now we're going to be concerned, because by turning it into a percent, we kind of controlled for the fact that, well, they might have lower overall revenue numbers, but because they have lower overall revenue, it should still be paying, their players kind of the similar percentages. And we can kind of look at, there's different demand across all these sports, not just for the WNBA. But if I'm just looking at attendance, what would I expect WNBA wages to be most similar to? Well, their attendance numbers are probably pretty similar to AAA. So if I look at wages there, probably pretty similar, although it's tough because AAA, like you're investing, right? There's some we talked about what's like investing in player capital or player skills, right? So we don't really have that in WNBA because that's like the last stop, right? That is the professional league. So why are they paid so much less for the same sport? Well, we kind of already looked at this. But if we look at ticket sale numbers, if we look at TV viewership rating, merchandise sales, they're typically significantly lower. Now, this isn't the true for every sport. For the WNBA, NBA, it definitely is, right? But if we look at something like figure skating, right? Female figure skating used to have like, I don't know if they still do. They used to be on like every Saturday because like my mom would want to watch it, right? Or maybe it was a Saturday or Sunday, one of the two. It was a terrible time slot too. It was like 1 o'clock in the afternoon on whatever the local station was. But you didn't see men's figure skating, right? It was predominantly on. So there are different sports where the reverse is going to be true as well, right? In fact, I think I've got a slide here in a second, but I believe women's gymnastics does significantly better in terms of ratings and attendance and things like that than men's gymnastics. So we kind of already saw how this works, right? Basically, the wages may not be coming as a result of gender discrimination, but based off of the fact that there's different marginal revenues per win for those sports. So we've already kind of looked at that. Here's the exceptions they had. So gymnastics, figure skating is one where when you look at the wages, they're actually higher for women, and all the indicators of like attendance and TV viewership are all higher as well, right? Which is, you know, could still be masking some discrimination, I guess, like even though they're getting a higher amount, you know, if there's a little bit of discrimination, it could push the wages to be not quite as high as they should be, right? Kind of like what we were talking about earlier. I don't know if I've got, this is kind of interesting. I think we've got enough time to go through it. So if we look at NCAA basketball, this is kind of a cool thing. It's not necessarily, I shouldn't say cool. We're not comparing players here, but we have a really good example where we have both men and women doing the same job, right, in the same sport, and that is NCAA basketball, right? So if we look at NCAA women's basketball, we get a pretty good mix of female and male coaches. So it could be, right, that we actually see reverse discrimination in that situation, right? Because maybe there's some discrimination against men coaches coaching female sports, right? And maybe not. Maybe there still is discrimination against women coaches and they're paid less. We can kind of see whether, which one is true. So men are more likely to be a men's basketball coach, which pays significantly higher than women's. But right, we also have women's basketball coaches where we see both, right? So which one do we think makes more? It's hard to say, right? You know, maybe people believe that men coaches are just always better at coaching basketball. Maybe some people believe that, you know, men can't coach women's basketball. So there could be discrimination going on in either direction. So the evidence, there's a paper out there and they looked at this and they actually found that there's slight evidence of gender discrimination towards men. That if we looked at coaching salaries, they tend to be a little bit lower for women's basketball coaches than women's basketball coaches. Right? They also kind of took a look at golf and found a similar thing, right? When men's coaches who were coaching women's golf were paid slightly less. Slightly less when men who were coaching women's golf earn slightly lower salaries than women coaching women's golf, right? So that there was a little bit of reverse discrimination going on for those female sports, right? Any questions on that before we keep moving? Shouldn't be too bad. So it's really just using the models that we already talked about to kind of think about just a different example, right? As opposed to kind of racial discrimination or foreign domestic, we're just looking at kind of gender, right? We would use the same models to determine that. 10 minutes left. I don't want to dive into things too much here. So we already went through this last class. This is all the amateurism stuff. Why do I think I put this in here for a reason? Oh, this is for when we talk about that. So next Tuesday, and then that video that we'll do, I'll kind of, we'll start looking through kind of college issues that are related to college athletics. We'll then look at some gambling stuff and then additional topics, and that really will kind of take us all the way through the end of the semester probably. So those are kind of the last three kind of topics. Now, as we get towards the end, I might just ask if you guys have interest in anything, and I may try to find articles to bring in and kind of build some additional models that we could look at. But the other thing that I wanted to mention here was, I forget who it is. I think I know who it is, but I'm probably not signed in. Oh yeah, I am. I think, just to give some people some credit here. So I think Will's going to end up winning. So just give you a little public, but you were very close. In fact, I looked at this yesterday. I think that you can't win because, yeah, like I forget what the team is that you have. So he's just going to just edge you out. But I won it, and also I did terrible at it. My bracket was horrendous. Where am I at? It's all the way down here. Yeah, so I'm struggling. So I did want to point this out though, because I think it's very interesting. I am kind of shocked by this. We'll see what ends up happening. But I decided, because you guys were doing it, I'd open up to my business stats and do it for them. This person is in the 97th percentile right now, and I believe they have Duke, Kansas as the final. So like if things play out the way this person has, I mean, I would imagine they're going to have one of the best brackets that exists out there. I don't know who it is yet. I have like a couple different people with the last name Parker, so I'm going to try to figure out who it is. But I thought it was kind of interesting. You're thinking about these brackets and you're looking at like the different probabilities. Some of, I think I can admit this because it's legal. So I do a little bit of like some gambling here and there through kind of the apps. Just as kind of fun, trying to see if I can figure out anything that the bookies aren't building into their lines. But one thing that we'll start looking at is how they come up with those gambling lines. So that's a little bit, like I said, that's kind of the next topic after we do college athletics. But that we'll kind of talk about how they set these lines, what they mean, and look at some pretty interesting stuff. Okay. All right. So I will see you guys on Tuesday. I might post the next homework up on Canvas, just because we're starting to work through some of the materials. So if you do want to start working on it, you can. I realize that we've already got an assignment that's going to, out there that you need to work on. But just in case people have finished that, I want to give you the opportunity to kind of start the next one. So if you see that pop up there later this afternoon or early tomorrow morning, that's why. Okay. All right. Have a fun, safe weekend, and I'll see you guys on Tuesday.